Welcome to the fifth week of this course. So far we have talked about plies or lamina. So, we have seen how we can deal with the non-homogeneity of plies and the anisotropy of plies, and we have seen how we can transform the properties of plies with respect to one global XY system. Now, we are in a position to analyze the laminates. So, we look at the macromechanics of composite laminates now. A composite laminate is a stacked assembly of multiple layers of plies, and each layers can have its different fiber orientations, and these plies are bonded together to act as a single structural elements. Now, let us assume that we have a few plies. So, maybe this is ply number 1 and that has a certain direction of fiber orientation. Ply number 2 that has another fiber orientation direction, and let us say we have another ply with again another fiber orientation direction. Now, these plies can be made of same material or other, there can be different fiber volume fractions. Still with all those possibilities also we can analyze a laminate. Now, let us assume that we stack these plies up in such a way that we put this as at the bottom layer and then we put another over that the ply number 2, and above that we put ply number 3. So, let us say that after stacking we get this laminate. So, layer 1 this one, layer 2 this one, and layer 3 we have, and that makes one laminate. Now, we can put them in a different sequence also. So, we could have taken this as 1, this as 2, this as 3, or this as 1, this as 2, this as 3, and so on. Now, depending on the sequence, the property of the laminate changes. So, it is not only which plies we choose, which fiber orientations we choose, but also at what sequence we arrange them, that also affect the behavior of the ply. Now, the question is why do we need different fiber orientation? Why can't we just stack one particular fiber orientation ply and repeat them? There are several reasons for that. First of all, if we choose different fiber orientations, we can cater for strength stiffness requirements in different directions. So, depending on the fiber orientation, each ply can be more stiff and strong in certain direction and less weak and less flexible in the other direction, flexible in the other direction. So, for example, if we look at this particular ply, so here the fibers are oriented in direction x. So, here x and 1 are intersecting. Now, this particular ply is stiffer and stronger in direction 1 because the fibers are more stiffer and stronger than matrices. So, this can take more load in direction 1, and in direction 2 or direction y it can take less load. Now, if I arrange this, if I take only this kind of ply and make a laminate, then what will happen is the resulting laminate would have more stiffness and more strength in one direction, and it would be relatively weaker in the other direction. Now, that is not always desirable. Sometimes it is possible that our structural requirement is such that we need strength only in a certain direction, but in most of the cases we need strength in different directions. So, in that case maybe a combination of these two plies and also with this we can make a laminate, so that these plies give strength in the other direction. So, with different combinations of these lamination sequence, with these fiber orientations in a lamination sequence, we can take care of the strength and stiffness requirements in various directions. So, depending on the strength requirement in different directions, we have to choose a particular lamination sequence. Apart from that, with proper sequencing, we can sometimes get rid of some kind of coupling and sometimes we can impose some kind of coupling. So, there are different types of couplings we will see in a laminate. So, for example, in an isotropic material, where everything is made of just one material, there is no thickness wise property variation, or even if it is there, the variation is symmetric. In that kind of cases, there is no coupling between the in plane deformation and out of plane deformation. But if we make these layers of different properties, which in composites, which we can do very easily by just changing the lamination sequence, and we make it asymmetric, which we will see quickly, which we will see in the next lecture. So, if we change the lamination, if we arrange them in proper lamination sequence, then we can impart those kind of couplings. So, when we need certain kind of couplings, we can go for a certain type of lamination sequence. When we want to avoid some type of coupling, we can again choose a different lamination sequence. So, with proper lamination sequence, we can go for different kind of coupling effects, which helps in tailoring different types of properties. Now, there are different composite lamination types. The first one we can write as cross ply laminate. Cross ply laminate. So, in a cross ply laminate, all the plies have 0 or 90 degree. So, either 0 or 90 degree orientations the plies have. So, if I make a laminate and say the laminate has 4 layers, so this is our layer 1, layer 2, layer 3 and layer 4. So, suppose the bottom layer is 0 degree, and then the next layer is 90 degree, then the next one is say 90, and then we have 0. So, all the plies, none of the plies have any angle other than 0 or 90. So, this kind of plies are called, this kind of laminates are called cross ply laminate. Then there are angle ply laminate. In an angle ply laminate, none of the plies have 0 or 90 degree orientation. So, orientation other than 0 degree or 90 degree. So, again if we say that our lamination layer 1 is 45, layer 2 is 60, layer 3 is 30 degree, and layer 4 is suppose 45 degree. So, in that case, none of the laminates, none of the plies have angle orientation which is either 0 or 90. So, this is a angle ply laminate, and we can go for a mixed also. So, mixed can have both cross ply and angle ply. So, for example, something like 0, 90, 45, 90, 0, that is an example of a mixed laminate, where we have both cross ply and angle ply mixed. So, that is a mixed with consideration to the fiber orientation. Now, there are different types of symmetries or anti-symmetries we can talk about. So, there is something called symmetric laminate. Symmetric laminate. So, in a symmetric laminate, let us again look at an example. So, let us suppose we have a laminate, and just let us assume that it has 6 layers. And so, it is layer 1 and up to layer 6. Now, when we talk about laminates, we always consider the bottom ply as the first layer, and then the number increases as we go up. So, here say the lamination sequence is such that we have 60 at the bottom, and then we have 45, and then we have 30, then 30, 45, 60. So, here what we see is with respect to this midline of the laminate, if we just go up the layer above it, the fourth layer, that is for 30 degree, and then just immediately below that we have 30. If we go further one layer up, that means we are in the fifth layer. In the fifth layer, the ply has a 45 degree orientation, and again if we go further down, in the second layer we have 45 degree orientation. So, with respect to this midline, we have 30 30, 45 45 and 60 60. Similarly, if we look at the bottom, the first layer we have 60, top we have 60. So, at the two symmetric locations, the plies have same fiber orientation, and not only same fiber orientation, they should have same thickness, same material properties also. So, same material property, thickness, and most importantly fiber orientation at symmetric layers. Then we call it a symmetric laminate. Now, it may happen that the fiber orientations are same, but the thickness is different. Say for example, layer 6 and layer 1 can have both 60 degree orientation, but suppose their thickness is not same or their constituents are not same. In that case, they might be symmetric with respect to the fiber orientation, but overall it is not symmetric, because in a symmetric laminate the kind of behavior that we want, we won't get it here. So, accordingly it can be symmetric cross ply and symmetric angle ply. Now, before going there, one thing here we talked about even layers. Now, even number of layers. So, the total number of layers was 6. Now, say that there is a laminate with odd number of layers, and still we can talk about symmetry. So, just let us consider this now. So, let us suppose that instead of total 6 layers, we have total 5 layers. So, we go from here layer 1, layer 2, 3, 4, 5. So, this is layer 1, this is layer 5, and let us assume that the sequence is like this. We have 60, 45. So, 60 at the bottommost layer, which is layer 1, then second layer 45, then third layer suppose we have 60, then fourth layer suppose we have 45, and the last layer we have 60. In that case, if we look at it with respect to this ply, this mid one, and then we draw a mid line here, and let us assume that the thickness and constituents are same all over. So, with respect to this mid line, we can again call it symmetric, because if we look just above it, we see one half of a 60 degree layer. If we just see below it, we see half of 60 degree layer. If we go further up, we see a 45 degree layer full, and if we go again here further down, we see a 45 degree layer full, and if we go at the top, we see 60 degree, and if we go at the bottom, we see 60 degree. So, with respect to middle of the mid layer, this ply is symmetric. So, here so this is also a symmetric. Now, there can be symmetric cross ply, symmetric angle ply. So, symmetric cross ply, that means it is symmetric as well as it is cross ply. So, an example of this kind of sequencing can be 0, 90, 90, 0, or if we go for odd number of layers it can be 0, 90, 0, 90, 0. So, in the first case it is symmetric with respect to the junction between these two 90 degree layers. In this case it is symmetric with respect to the middle of the 0 degree layer. Similarly, there can be symmetric angle ply also. Again the name suggests everything, it is symmetric as well as it is angle ply. So, it is for example 30, 60, 60, 30, this can be a symmetric angle ply laminate. Whatever we have seen here 60, 30, 60, 30, this is also symmetric angle ply because with respect to the mid layer 60, this is symmetric, and we can go for a mix also, but if we can choose both the cross and angle plies, and then if we stack them symmetrically we can get a symmetric laminate also with mix sequencing. Now, there is something called antisymmetric laminate. Antisymmetric laminate. In an antisymmetric laminate, at the symmetric layers the fiber orientations are just opposite. So, again let us think of a composite laminate, and just for simplicity we will show only one side of it, we will not draw a 3D view, and let us assume that it has total 4 layers, and let us suppose the angle is 30 degree here, then here the angle is suppose 45 degree, then here we have minus 45 degree, and then suppose we have 30 degree here. So, we have 30, 45, minus 45, minus 30 starting from the bottom. Now, if we look at with respect to this midline, that means junction between this 45 and minus 45, if we see up we see minus 45, if we see below we see 45, just opposite of each other. Similarly, we see at the top we see minus 30 and we see 30 here. So, that is an antisymmetric laminate. So, we have minus theta and theta at every pair of symmetric locations. Now, again, so with antisymmetric laminate also we get special type of laminate behavior, and for that the thickness and material properties also have to be same as we have discussed before. Now, these antisymmetric plies can be symmetric, antisymmetric, angle ply, which is basically this what we have seen. So, the angles are theta or minus theta, where theta and theta thetas are neither equal to 0 nor equal to 90. Now, there is something called antisymmetric cross ply also. In an antisymmetric cross ply laminate, 0 and 90 are considered to be opposite. So, we have here we should have 0 and 90 degree at two symmetric locations or symmetric layers. So, whatever we saw theta and minus theta, that applies to angle ply, and in antisymmetric 0 and 90, there are only two possibilities in a cross ply laminate, either 0 or 90. So, those two are considered to be opposite of each other. So, again a laminate like this, so this is layer 1 and up to layer 4. So, if we lay them up like this, we have 0 degree, then we put 90 degree and then we put 0 degree and then we put 90 degree here. Then with respect to this midline, if we look up we see a 0 degree ply, if we look down we see a 90 degree ply, and 0 and 90 are opposite of each other. And similarly, if we look further up we see 90, and if we look further down we see 0. So, this kind of sequencing is an example of an antisymmetric cross ply sequencing. Again, the difference between antisymmetric angle ply and cross ply is, first of all, angle ply means it is the orientations are either in anything but 0 and 90, and in a cross ply they are either 0 or 90. In an angle ply they have to be opposite of each other, so 45 minus 45 and so on. In cross ply, so 0 and minus 0 they are basically same. So, in cross ply 0 and 90 are considered to be opposite of each other. Now, there is something called balanced laminate. Balanced laminate means balanced. First, let us look at balanced angle ply. So, balanced angle ply means number of theta and number of 90 are same, sorry, number of theta and number of minus theta are same. If we again look at a laminate like this, and let us say that this has total 6 layers. So, we have layer 1 to layer 6, and if we arrange them up in this way, we have 30, then say we have 60, then say we have minus 30, and then say let us suppose that we have again 30 and then minus 60 and then minus 30. So, here what we can see is total number of 30 is 2 and total number of minus 30 is also 2. Similarly, total number of 60 is just 1 and minus 60 is just 1. So, number of plies with plus theta orientation is balanced by number of plies with minus theta orientation. So, that is why we call it balanced laminate. Similarly, if we would have put them in a little different way, maybe 30 minus 30, 30 minus 30, 60 minus 60. So, the same combination of plies, but with a different sequence. Still we can see number of 30 is 2, number of minus 30 is 2, number of 60 is 1, number of minus 60 is 1. So, this is also balanced. Accordingly, we can think of balanced cross ply laminate also. So, in that case, we can say that number of 0 and number of 90 are same. Now, here is one thing to note: a laminate which is balanced does not necessarily have to be antisymmetric. For example, this laminate, although number of theta and number of minus theta are same, number of 30 and number of minus 30 are same, number of 60 and number of minus 60 are same, but they are not put in a symmetric position. So, if we look at here at the 4th layer, alright. So, this is antisymmetric. So, this is a balanced, but this is antisymmetric, by balance as well as antisymmetric, I would say. So, if we look at the layer just above the mid layer, so layer number 4 and just below the mid layer, layer number 3. So, they are opposite of each other. Similarly, layer number 5 and 2 are opposite of each other. Similarly, layer number of 6 and 1, they are also opposite of each other. But here when we change the change the sequence, we do not see it. We can see that layer number of 4 and 3 are opposite of each other, but layer number of 5 is 60 and layer number of 2 is minus 30. So, they are not opposite of each other. Similarly, they are layer numbers, if we look at layer number 6, that is minus 60, and layer number 1, that is 30. So, they are also not opposite of each other, but they are balanced. So, this is not antisymmetric. but both are balanced. So, a balanced laminate does not have to be antisymmetric always, but on the contrary an antisymmetric laminate is always balanced. So, these are various types of laminates that we can go for depending on the sequencing. Now, this lamination sequencing is denoted by some notations, and these notations are quite universal, I would say. So, again we know that in a composite laminate the layer numbering always starts from the bottom. So, we have layer 1 and let us say, just to be more generic, this is layer n. So, layer 1 has orientation theta 1, layer 2 has orientation theta 2, layer 3 has theta 3 and we go up to theta n. So, when we write it in this form using the notations through which a lamination sequence is denoted, we have to write like this. So, if we put it under square bracket and then we separate them by these vertical lines. So, for example, let us go for with proper numbers. Let us suppose that we have a 4 layer laminate and this is 30 degree, this is suppose 45 degree and say this is 30 degree, this is 45 degree. So, we can go for like this 30, 45, 30 and 45. So, if we just show this denotes that we have a composite laminate made of 4 layers and starting from the bottom the sequencing of orientation is 35, 45, 30, 45, 30, 45. Now, in this particular laminate it is neither symmetric nor asymmetric nor balanced. So, we can just call it asymmetric laminate. Now, say we have a symmetric laminate. And just let us have some more layers. So, let us suppose that the sequencing is 30 degree, 60 degree, 45 degree, 45 degree, 60 degree and 30 degree. In this case, as per our notation, the sequencing is denoted as 30, 60, 45, 45, 60, then 30. Now, because it is symmetric with respect to this, so we can write this as 30, 60, 45 S. Now, let us suppose that we have a laminate where we have odd number of layers, but it is still symmetric. So, something like this 30, 60 and instead of 2 45s, suppose we have 145. And we have seen before that we can still call it symmetric, because with respect to the middle of the mid layer, in this case the 45 degree layer, 45 degree layer, we can call it symmetric. So, in such cases it is denoted as 40, 60, 45 with a bar and symmetric. That means, with respect to half of this 45 degree layer, this laminate is symmetric. So, there are odd number of laminates. Now, it is so these are all symmetric laminate notation. Now, let us assume that there are two consecutive layers of same orientation. Possible? Let us suppose we have 30, 45, 45, 60 and then 60, 45, 45, and 30. In this case, we just put a suffix to denote how many layers are there in 2 consecutive positions. So, this can be written as 30, 45 with a subscript 2, that means there are 2 layers with 45, then 62 and then 45 2 and then 30. And again we can see that there are two 60s, and with respect to the junction between them, this laminate is symmetric. So, this can be further reduced to 30, 45 to 60 and then symmetric. Now, we can write antisymmetric laminates also. In case of antisymmetric, we generally put A or AS. Again, if we go by this example, 30, 45, 45, 60 and then we have minus 60, minus 45, minus 45 and minus 30. So, this is antisymmetric with respect to this. So, we can write this as 30, 45 to 60 and A, that means it is antisymmetric. Now, there is a it is possible that plies have different material properties. It is possible that plies have different material properties. So, let us suppose that the first ply, that is made of carbon fiber, second ply is made of glass fiber and this repeats, and again we have carbon fiber. So, let us suppose that this is made of carbon fiber, these two are made of glass fiber and this is carbon fiber. So, this we can write as 30 and then we put C at the bottom and then we can write 45 C and then symmetric with respect to that. Similarly, if there are multiple layer of 45s, so in this case because it was symmetric we did not have to put P. If there were 2 30s, then we could have just put 30 and then 2 C, that means 2 carbon fiber layers of 30 degree. There can be, it is also possible that the thickness is different. So, let us say that this same fiber has a thickness 0.25 millimeter and these two have thickness 0.5 millimeter each, and let us say that this is again 0.25 millimeter. In that case, what we do is we generally put a slash and put 0.25 and I mean write the thickness and write 0.5 here. So, there are various ways, I mean there are various things to denote in a laminate. If it is made of same material and same all the plies have same thickness, we generally just write the angles of orientations. If it has different materials, especially different fibers, then we denote them as subscript C, G for Kevlar, K and so on, and if it has different thickness, then we put a slash and write the thickness also. So, this was about various types of laminates and how we denote them through the lamination sequencing notations. In the next class, we will talk about laminate stiffness. So, let us end this lecture here. Thank you.